Okay, hello everyone, and thank you for joining us for today's webinar, From Design to Prototype with Formlabs 3D Printers. So before I begin, let's just cover some housekeeping. So attendees are automatically muted on entry. If you have any questions, please write them in the Q&A panel, which is located below. And we will answer them after the presentation. For any additional information, of course, we are available at info@IB-CADDY.com. So today's panelists are Rok Wojska and Rok Żabker from IB-CADDY. They offer technical support for SolidWorks and 3D printers. Also joining us is Jakub Doberow, who is a Pro Services trainer from Formlabs, and he's one of the longest standing members in the EU team. So a little bit about our company. So IB-CADDY was founded in 1991, and we are currently located in Ljubljana and Kamnik, which is located in Slovenia, and we also have office in Beograd, Serbia. We cover different fields of industry, going from engineering design all the way to manufacturing production. We are resellers for SolidWorks, CAM softwares, 3D scanners, and 3D printers. One of the products that we offer is Formlabs 3D printers. So I think it's the best way for me to just give the word to Svetlana, who will tell us a little bit more about Formlabs and the products they offer. So I think, wait. Yeah, Svetlana, I think you have the floor. Yeah.
Hello, everyone. My name is Svetlana Budilovska, and I am a marketing manager here at Formlabs. I am joining you from the Berlin office, and I'm going to introduce you a little bit into Formlabs. What is Formlabs and what do we do? So Formlabs was, sorry, too fast. Sorry, Formlabs was started in 2011 with a Kickstarter campaign, and we were founded in Boston area and MIT Media Lab, and we launched our first printer in 2012. Sorry, it's going a little bit too fast or too slow. Right now we offer, we have more than 500 employees, and we have offices all over the world in US, in Europe, and in Asia. What is Formlabs' mission? So we are expanding the access to digital fabrication. That is, anyone can make anything. What does it mean? That means that we have printers that are very easy to use, so anyone can actually use them, and whatever you think you might want to print on a 3D printer, you can make it. It depends on your vision. Right now, this is a little bit of what did we do over the past 9 years. We launched the Kickstarter campaign in 2011. In 2012, we launched Form 1, which was the first desktop SLA printer. Before that, there was SLA exists from 1984, but there was never an affordable printer. All of the printers more or less started from $80,000 back in the days. And there was a big market for the affordable desktop printer that you could basically put on your desktop in the office or at home. Since then, we've launched a lot of different products, and right now we offer Form 3, Form 3B, and our newest printer, Form 3L. 2020, right now, we offer Form 3 and Form 3L, which is the bigger version of Form 3. The build platform was more or less 3 times bigger. Form 3B, where B stands for biocompatible, where you can print any biocompatible resins for dentistry or medical industry. With wash and cure, with post-processing applications, and our selective laser sintering printer Fuse One that is coming later this year. What industries you can use 3D printing? Well, pretty much anywhere. You can use it in engineering, from prototyping and product designers to creating some parts during the manufacture process, like jigs and fixtures, for example. In dental, we have a lot of biocompatible resins to print dentures and custom trays and everything that you might think of in the digital dentistry workflow. In the healthcare, you can print a part of a body or an organ to teach the students or to talk to the patient when there is a need of a surgery, for example. We also have printers and resins for the jewelry, where we have some different applications to print very thin details and very specific details that are in need for the jewelers. In education, as I already mentioned, for medical or for any other industry, and also for the audiology. We offer a very big amount of materials. We offer more than 20 different resins that can be used in different applications, from standard resins to dental resins to the engineering and jewelry one. So whatever industry you work in, you can always find a resin that can be suitable for your needs and your applications and your workflow. With that, I will pass the ball to my colleagues that will go in deep with you on how to actually do the workflow from the SolidWorks to the printers. Thank you.
Thank you, Svetlana. Hello from my side. My name is Rok Vajska. I'm from IB-CADDY company. And in today's webinar, we will be showcasing a workflow from design in SolidWorks to 3D printing prototypes with Formlabs 3D printers. And afterwards, we'll have a Q&A session. Today, I'll be taking the role of a project manager, where I will be supervising the flow of the project and communicate with my team. For me and my team to do our work efficiently, we will be using a product by D.O.O system called 3D Experience. D.O.O system is also a company who basically owns SolidWorks. And it's a cloud-based platform that you can basically access through a browser on any device that has basically internet connection and access to a browser. In this platform, you have wide range of applications, and these applications are either for communicating, for modeling, for data managing applications, simulation, live chat, and many more. Basically, there can be hundreds of applications. And you can imagine this platform as a blank page, which you can fill up and customize with all these applications the way you want. You can create the new pages differently for each new project. So you can basically adapt your workflow based on what your role is and what the project basically demands of you. Here, which you can now see on my screen, I have opened two applications called Web Page Reader. On the left, I have our IB-CADDY web page, and on the right, I have the web page of Formlabs. And I have also created a communication page specifically for this case. On the left, we have 3D Stream. This application allows me to communicate with my team allows me sharing links, images, videos, and also various files, as well as doing audio and video calls. On the right, I have a task application where I have 3 columns: to do, in progress, and done. So basically, I can create tasks, assign them to a specific person, and I can follow the workflow and see where we are with the project at a given moment. And basically, just to show you how easy it is, here I open the logo, and on the left I have all these different applications. Now I'll just put in the web application, and I will use the Formlabs library, material library. So while I'm communicating with my colleague, I can also check these materials that Formlabs has available. If, for example, like this, then I can just make it look a bit nicer. The second page that I also created is I call it the models page, and basically here I imported 2 applications. One is 3D Play on the left, which allows me to view various files. They can be 3D files, they can be document files, videos, like a huge range. And on the right, I have application 3D Drive, where me and my colleagues, my team, are connected to this one folder where we can share our files, in this case 3D models, and any changes that are made are updated through this 3D Drive for all of us. So there can be no miscommunication about which version is the right one and so on. So yes, today we'll be focusing on this hood hinge part. And what we want here is to make this part a bit lighter. And of course still functional. So what I'm gonna do, I'm going to let my colleague know that I want this part to be optimized and to create a few files. So I'm just going to send him conversation. I'm going to create hood hinge printing description. I want him to create 3 STL files. I want them to be solid, hollow, and then optimized. IB-CADDY and it is correct. And just make sure that I have. Okay, and then I just select publish. And then my colleague will receive this notification, and he will be able to start his part, where he will basically show us in SolidWorks how to create this part. So here in communication, I am going to also create a task named create the models for printing. And just add it. And here we can see that it's on the do list, but I'm going to set progress because now Rob has received the information, and it's basically his part to prepare me the files so I can check them and then send it over to colleague to prepare it for printing. So, Rok, if you could change.
Okay, thank you. Thank you, Rok. Hello, everybody. So Rok, as the project leader, has told me that he needs a part modeled for the hood hinge assembly. I will do this in SolidWorks. So most people know what SolidWorks is. But let's go through the basics. SolidWorks is a feature-based parametric 3D CAD design software. That's a long description. So what does this actually mean? Let's look at this as the in SolidWorks. So basically in SolidWorks, I will now open the part that we will be working on. Of course, this part that you can see on my screen now, this is modeled in the computer. So this is the first meaning of the description. This is CAD, computer-aided design. Let's look at the other descriptions for SolidWorks. So first of all, we see that the part is already partially completed. I only have a few steps left to do before I can send it back to Rok. First is to make this cylinder fit in a bit better with the rest of the model and add a few holes. Let's start with the cylinder itself. The simplest way here is to create a fillet. Now, a fillet, I choose what the radius of the fillet is. In this case, it will be 1.5 millimeters. And this 1.5 millimeter fillet, this 1.5 millimeters is actually a parameter. Everything you do in SolidWorks is controlled with these parameters. And that is the second part of the description. SolidWorks is a feature-based parametric 3D CAD modeling software. Okay, and this now looks okay. Let's look at the left side of my screen. Here we see something called a feature design tree. A feature design tree is the basic outline of how the model was created. If we look at the end, we can see the fillet. This is the fillet we just added. This fillet is a feature. So every step that we do to create a 3D model is basically a feature. Either we add material, we remove material, however we want it. So I like to think of features as basically as Lego blocks. You use one block and another block to create a geometry. This is similar in SolidWorks. You use one feature to add some material, another feature to remove some material, a third feature to split the model, and so on. Now, to finish this model that we are working on, we just need to create 2 more holes. That's very easy in SolidWorks. We just create a 2D sketch and create 2 circles where we want the holes to go. We will dimension these holes, and these dimensions are again parameters just like we saw with the fillet. And once we define the holes, let's just remove the material. And that's it. That's the first of our 3 models that Rok has requested done. So what do I do now? Basically, I have to save it and send it to him. Now, we will be 3D printing this model. So I will not be sending him a SolidWorks model. I will be sending him an STL model, which the printer can read, or basically the software that communicates with the printer. That's not a problem in SolidWorks. We have a lot of different file formats that we can save into, and one of them, of course, is STL. I will be saving this back to the 3D Experience platform, like Rok talked about earlier, into the 3D Drive application. So this is now being sent to the cloud, and everybody will have access to it. This is the first of the models. The second model is the hollow model. Now, the hollow model is already created. I already created it beforehand, but right now it looks the same. Well, that's basically because it's hollow and the inside are gone. So the volume of this whole model is a lot lower than the full model. And we have another model to prepare. So the hollow model, as I said, was prepared beforehand, and that is to optimize the model. So in SolidWorks, when we talk about optimization, we talk about basically a lot of the times removing mass. So this is an ideal situation for 3D printing, since if we remove mass, remove material, we use less material, the part is then cheaper. So, but before I can optimize this model, I have to make sure that it will withstand the forces. It needs to as is. So if it's strong enough as is, then I have some room to play. I can remove some extra material. How can I check this? With SolidWorks simulation. So SolidWorks simulation basically is a module in SolidWorks where we can simulate the parts and how to if they will they will withstand the forces they need to be exposed to. For the simulation, the first thing to do is define the material properties. In SolidWorks, we have a large library of materials. However, you can also create your own materials, like I did here. I created a Formlabs tough material. The second step is to fix the model into place. In this case, we will say, okay, these areas are fixed. And the last part is to define the external forces. A force here, but we still need to set the direction of the force. So let's set it for the top plane. The first force will be, let's say, 25 newtons in the direction of the arrows. The second force working in the same time, again 25 newtons, however, in the other direction. And the third force, 150 newtons downward. So this is basically everything we need to define. Now we just have to mesh the model and run the simulation. Here we will quickly see what the results will be. If the model is strong enough, we can have some room to play to remove extra material. So in here we see that the maximum stress in the material is 16 megapascals. The material can withstand 55, so we're good. We look at the displacement. Okay, the model will displace about 2.5 millimeters in this direction. And to look at the factor of safety, everything is above the factor of safety of 3. So the part is okay. Okay, this was a simple static analysis. Now let's look at how we will optimize the model. We will optimize the model using the topology optimization module in SolidWorks simulation. This is a bit more complex simulation, but for a user, it's still basically the same. You define the material, you define the fixtures, the loads, then you define what your goal is. The goal in this case is best stiffness to weight ratio. The end, of course, you can control some manufacturing controls like preserved region. In this case, I want the blue faces to remain as they are. And after a short simulation, which was still longer than the static simulation we just did, we can see what material we can remove. Now, from this side, it looks the same because, as I said before, these are the areas I want to keep. However, if we go to the other side, we can see how much material was removed. So using the simulation, I calculated that I can remove this material, and this is my new optimized model. And of course, this I can now save as an STL and send back to Rok to check everything. Okay, and Rok, if you can take over.
Thank you, Rok. Okay. Thank you for the files. So basically now, thanks to the 3D drive, all the files in the folder that we are sharing together are automatically updated. And I can just simply drag and drop them into the 3D Play, inside this 3D Experience platform, and check them to see if everything is okay. Here I have the full one, the solid one. Here is the hollow one, which has holes that are needed for printing with Formlabs printer, which Jakob will go in more detail. And also the optimized part. Here I can see if everything is okay. Just to show, I can also simply drag and drop PDF files. Here, for example, a Formlabs datasheet. And basically the models look great. The communication tab, I can progress of creating the model has been done. And all I can omit is the print prototypes. I'm going to put them in the progress. Now is Jakob's turn to take over and show us how to prepare and print with Formlabs 3D printers.
Yeah,
so Jakob,
thank you, Rok. So let me share my screen right now. So now you should be able to see our preform software, which, by the way, you can get for free on our website, just formlabs.com. And even if you don't have a printer yet, you can just download it, input your STL files that you have exported either from SolidWorks or other CAD programs. You can just put them in here and see, for example, how much resin they will take, so you can have a little bit of a cost analysis. You can also see how long approximately those models will print. So as you can see in the background, I have already cheated a little bit as I have already opened these files in here, but I just wanted to show you this real quick, which is the job setup page, which is what you will be greeted with every time you start preform up. So in here, it's pretty simple. You actually just have to select which resin you would like to use. And as Svetlana has told you before, by now, we have a little over 20 resins if you actually consider the dentures where we have different colors as individual resins, then it's closer to 30 actually. And then you can, for example, also just go to our website, which Rok has already showed you a little bit about. And we have all the information about all the resins there. So for example, this is a comparison of the 3 resins that we currently have in the Duratough family. So these have varying degrees of flexural modulus and speed at which they bend and bend back. So you can use these to make like snap fits, for example, or the durable resin you can, for example, as it's so soft, you can use for living hinges, for example. But now I will just use the TOUGH 1500 as this is a very nice and general prototyping resin, and you will also select the layer height that you want this to be printing at. Most of you who have maybe been in touch with 3D printers before know that we are always printing these models, as it's also called additive manufacturing, in these individual layers. And the thinner these layers are, the smoother, typically speaking, your surfaces are, but also your print time increases. So for SLI printers, most of the time 100 microns, which is 0.1 millimeters, will just be fine. So I'm hitting apply here. And that is all that you have to do in terms of material settings or so. Some of you, especially those who have FDM printers, know that it can sometimes be a pain, that you sometimes have to set how much fan speed you're putting on this, how's your bed temperature, how's your extruder. Now you're using PLA from a different brand. Now you have to do 3 degrees fewer or 10 degrees more, and then maybe your PLA has drawn a little bit of moisture. So in here, it's very easy to just go in, select the resin, and all of the material settings are already pre-programmed that you don't have to touch anything about it. And that's also why we hide this from you, basically, that you can't touch any of this, because we want this to be like a general platform to just use in here. So I have the 3 models in here by now. Right now, they all look the same. If we cheated and looked to the other side, we could actually see that these are different. But another thing I want to show you real quick is the slider that we have on the right side here. This is a tool that some of you might be familiar with from other CAD software. So this is a pretty cool thing where we call it a slicer, where you can actually go in, and if you zoom in far enough, you can, I hope this picks up on the screen share actually, where you can actually see how the laser moves in these individual layers. So if you have a little bit of experience using the slider view, you can actually also use this as a little bit of a check to your wall thicknesses, for example, if you didn't do any errors in the CAD program. So now we can see that this one on the left is the hollow model, the one in the middle is the solid one, and then we have the topology optimized one on the right here. So for all 3 of these, I would want the mass of the model to be closer to the build platform. So what I will do is I will actually orient all of them at the same time for the first little bit. So I will just, whoops, that was the that I clicked on. Sorry. So, man, I should maybe go make another coffee. So this time it was correct. So I will just be pushing over like this. And then as I want the supports to be more on this side where it might be easier for me to take them off, I will also give them a little bit to the back side. So for 2 of these models, for the solid one and for the topology optimized one, this is actually quite nice. This one, however, which is the hollow one, I will have to do a little bit of a different orientation to right now, because Rock has already told you about this a little bit. As we have this hollow model right here, we actually have a little bit of a risk that we're running into here. And I'm going to show you this in a minute here, but the gist of it is we're printing a hollow model and we're using a liquid resin that we're basically printing this in. So imagine you take something like a standard coffee mug and you want to just wash this in your sink. If your sink is full of water and you take your coffee mug and you just push this into your water there in the sink, then you will actually have a suction cup right here that can have some forces being applied to the outer and inner walls of your model. We don't want that. So what we need to put in are a couple holes into our model. Basically, you only really need 1, but it's usually easier to work with if you have 2 or so. So we need a hole like this one down here. Let me actually just hide the other 2 so it's easier to see. So we need a hole like this one to solve this suction cup. And actually, preform will help you with this. So we have these automated functions in here. If I tilt this too far, this is actually not fitting the build volume anymore. So I can push this around. Preform will typically show me, hey, that there is something going on here, and I have a little bit of a warning that I can't be printing it like this. So we have these functions in here to help, but I'm just gonna press Ctrl-Z. So I can use the slider right here to just check how long this will be a suction cup for. So we can see the suction cup forming in here. And then already a little bit further up right here, the suction cup is already solved to the outside. So this is 60 layers right now, it tells me on the side. It actually starts a little bit later than the first layer. So I have to think about it's 6 millimeters of height. So that's well under the threshold that I would have to care about. But if I really was thinking about it, I could also tilt this to the other side so that this hole is on the bottom side and it's immediately solved. So this is what I wanted to do for orientation here. So I have already also pushed them basically to the back side like this, because if I were to take these and put them to the side, and I would generate supports, you will see that in a second here, I would have a lot of supports on this topology on the inside here. I don't want that to just because I can damage it when I try to take the supports off, and the surfaces will, but generally speaking, not look as nice. So I'm tilting it this way. And basically what I'm doing right here is I'm thinking a little bit of ahead where I want my supports to be at, what I'm doing in terms of orientation. But if you really want to be a little bit lazy, or if you're just starting out, it's just fine up top here. You can see this little wand. You can also go in here and just have preform do everything for me. So I don't have to do all of this by hand. It's just mostly good to use these automated functions in the beginning. And then when you have a little bit of training with the printer, most of the time, as these algorithms are just fine and they work well, but most of the time you can do a little bit of optimization by knowing this print process pretty well. So after doing the orientation, my next step would be to go into the support mode. And I will just go in here, and from my knowledge, I know that I can already put down the density. This means that I will have a couple fewer supports, and I will let preform just generate supports on these models right here. This takes a minute, and then after the supports have been generated, I will just take a quick glance at them and see how well they have been generated. And for parts like this one right here, for example, I know that now due to the orientation of the part, that I will have a couple supports on these parts right there, which might be a bit thin. So I can just go in there and change the supports a little bit. I can see that while we're waiting for the supports, there is actually a nice question in the Q&A that I'm picking up right now while we're waiting for the supports to be generated. So there's a question in here, if the Formlabs printers support ABS printing. No, they do not, because that is a thermoplast. All that we have with these printers here are resins, but that we have, for example, the tough 1000 resin that we have was very specifically made to make ABS specifically made to mimic PP properties, and then durable is made to mimic PE properties. So as we're always using these thermal sets here, and support generation is also done in the meantime, we are limited to these thermal sets, so we can't print in thermoplasts. But we have some specifically in-house engineered materials to mimic these. So as you can see, we have quite a few supports on here, and some of them, especially those that you can see in the channels there, might be a bit harder to take out without damaging the channel a little bit. I'm just going to be doing it for this one model here. But what you can do in the support edit mode, you can just in here, and then it's very easy for me to see all of these support attachment points. I can just go in here and take out these supports that I don't want on these individual points right there. And you can also see that the algorithm and preform determined that these edges right here were a good place to put all of these supports. But as you might know, if you have supports that just go to an edge like this and you try to clip them off or use a little bit of a knife there to cut them off, it might be hard to preserve this sharp edge. So even though these supports are positioned correctly, I can also just take them away and then just put a new one slightly more inward, where it's easier for me to set on a little side cutter and then cut them off flush and very nicely. What you can also do here, for example, is go down in touch point size. So if I have a detail like this one, where I want these supports to not be as big, I can also just mix and match tinier supports in here. For this, as it's a model that has quite a bit of mass, I will just put maybe 1 or 2 extra supports in here just for good measure. But if this is something where I want this to be preserved, this surface to be preserved as much as possible, I can just exchange some of these supports for smaller ones. And then I can mix and match however I want. So if you have models that have some surfaces or some very small details, you can actually mix and match, and you can see that these are nice and small, while these that hold the general model are still nice and big. Are there any guidelines? Yes, definitely. So you can either just get in touch with us or with our colleagues here from IB-CADDY, and we will always be helping you out with these models and with everything that you want to do here. But if you just go to our website, formlabs.com, on the top right, what you can do is you can find our support pages there. And in here, we have quite a few articles on the Form 3 and the Form 3B, which is the same printer, but you can print biocompatible resins. And also in the software section, you can find quite a lot about how to orient your models and where to put supports and the kind of thing that we would be helping you with, basically. So, but you can always feel free to basically make a file and then just send it into our support team, and then we can help you with and tell you like, hey, this looks super nice. You can just send it to the printer, or we will be like, hey, have you thought about changing this one thing about it? So for this one right here, you can actually see that there's quite a bit of red shading going on for this model that basically just means that this is a little bit of an under-supported area. So I can also just go in here and just put in a couple supports. I'm just eyeballing these right now because due to my experience, I know how much I will need for this. And I can hit apply to be generated. And then all that is left to do is just organizing these a little bit on the build platform. We also have an automatic layout feature that you can use. I'm just being lazy right here right now to just go a bit quicker. So I will just move these around on the build platform so that they don't overlap. But like I said, you can also use the automatic layout function for this. And then the last thing to do would be to just send it to the printer. So I'm pressing this orange button right here. And in this case, I can just select the printer that I have either in my network or I have this attached to my computer via USB. In this case, it's my printer Gullible Spider. That is the serial name of this printer. So I will just select that one and I can upload this job. I can actually give it a nicer name. Maybe something like 3 times hinges or hinge. And then I will hit upload. Prepare that. So let me very quickly just change microphones. This will be a bit more quiet than the one I'm using right now.
So test. This should hopefully be loud enough. I hope you can still hear me well. Nice, I'm getting a couple thumbs up. And then all I will do is just go over to my printer that I have set up here. So this, in this case, is a Form 3B, which you can see by the white shell that it has. And basically for the printing process, except for the print itself, we always need 3 things. So we need the resin itself, which comes in these cartridges. These are filled with 1 liter of resin each. So all we will need to do is just pop it into the back of the printer, and it has a little bit of an air vent at the top. So I'm opening that up so that air can go in the top so that resin can come out the bottom. And then for the inside of the printer, basically I will need a build platform like this one that I have right here, where I will be printing these models on, and that just goes in the top. And then I will need the resin container that sits at the bottom, the resin tank we call it, which always comes in these neat little boxes. And in this case, as I have been printing in this material before, right now I have the clear resin right here, but as I have been printing in this resin before, I have a pre-filled tank right here. But if I would have never printed in that resin, I would be taking a completely new tank. So I just insert it into the printer. You may be able to hear that little ping sound that I just got from the printer itself. And you can already see that the file is coming into the printer. It might be hard to see. I hope none of you are getting nauseated by this, but I'm going to zoom in a little bit with my camera here. But you can see that the file is actually coming into the printer. It's currently sitting at 17%. So right now it's going through my network right here. So in this case, if it's done, I would have a little button down here that would just say start, and then I would just press start, and then the print process would go from there. And that is basically all you have to do. After the printing process, the build platform will be all the way up to the top. And then when the build platform is all the way on the top and your models hang upside down, all you have to do is take the models off the build platform and then wash them in isopropyl alcohol, because there will be a little bit of liquid resin on the top surfaces, just due to us always pressing the models back into the resin tank at the bottom here. So you will have to wash that off. And after the washing process and after thoroughly drying out your parts, you will just put them under UV light to basically finish the stereolithography process so that these models reach their full mechanical properties. It really depends on what you're doing here. Some models really need that. For example, the flexible materials, they really need the post-curing process. But some of the ones, like the stiffer ones, the just general standard resins, we call them, that are just nice and rigid materials, those you don't even have to post-cure if you don't want it to. And that is basically all from my side. I think one of the other guys just wants to take over for a little bit, and then we will jump into the Q&A section afterwards. Thank you so much.
Yes, thank you, Jakob. So here we have great printed optimized part, and also on top printed a hollow part. And these parts will be basically used for prototyping. The tough part is especially because it is more durable and more for functional prototyping than the standard gray resin. But both are basically can be used for either visual presentation or also for basically functional prototyping, testing dimension, to check any dimensional accuracy, and then we can return to CAD files to change if anything is needed. So basically what I can also just do is upload the pictures of the files to so our team can see that the parts are finished and that this stage of the project is basically finished. And so we thank you for attending. And also what I would like to point out, if you're interested in buying a Formlabs 3D printer, you can go to our website and also order a sample so you can check the quality of the materials and the 3D printers with your with Formlabs, with your own eyes and with your own hands. So basically, that is it from our side and today's presentation. What will I just we will now go into the Q&A section. Just a moment, like this. Okay.
Yeah, there already is a nice question in there, and this one I would like to take actually. So there's a question here, could you elaborate a little bit on post-processing and how visible are the support marks? So that comes down to a couple things. So first off, let me share my screen real quick so I can show you a little bit more on the post-processing. So I'm again in the support pages. So for the finishing part, I just want to show you it real quick. So in the finishing parts, you can see both of these devices that you can get additionally for the printer. So the printer will always come with this hand washing station basically. And what you can get additionally is the foam wash and the form cure. So basically those two devices will take a lot of the work of your hand. Is there a nice, let me see if I can find a nice picture of those. So basically for the post-processing, especially if you have the foam wash and form cure, then you don't really need, there they are, then you don't really have to do quite a lot. On the point, and these would be those two devices where you can just take the whole build platform on the left and have it be pre-filled with this IPA. We have little tables on our webpage that you can download on how long to wash the individual materials and how long to post-cure them for. So you can just set these timers and basically set it and forget it. Sorry, I had to do it. And for the post-processing on how well you will see these support marks, let me actually stop sharing my screen. And let me just grab a couple models. So it basically boils down to how much time you want to invest and how much you want to do. So what you can do very easily is, I hope this gets picked up by my camera if it stops zooming into my face. So here you can see, for example, a model where I just took the supports and just ripped them off very violently, because I didn't really care about these surfaces of this model, because I just needed to fit it into the holder that it was going into. So you can see some of these support marks on the surface of my model. What you can do, however, is also check out whether or not you want to tilt your model in a little bit of a way to have support marks only in specific areas, for example. So this would be a nice example of what you can do there. You can also just print completely without supports. So if you have models like the skier, for example, that you can just put flat on a build platform, you don't have any support marks, and this is the surface finish that comes from the build platform itself. And then this is what that will look like approximately. But what you can also do is, especially if you use something like the clear resin, this is the last one I will show you here. So I printed this, not sure what they called in English. In German, they're called Hellfeldlinsen. So this is a device to basically help elderly people with reading, by the way. So you can just take this and then put it on things to be able to read stuff. So you can see right here that it's also very easy to just polish this up to a complete transparent finish, for example. This is what the surface finish was when I just took it out of the printer and didn't do anything to it. And this is after polishing for about 3 or 4 minutes. And then for polishing, for example, you can just use sandpaper and pastes that you would typically use for acrylics. Those work quite well, actually. Yeah, and thank you so much for the question. That was a pretty good one.
I would also like to point out about the dashboard that Formlabs also gives to their customers. And basically, it's a browser dashboard where you register your 3D printer. And it basically collects all the information when you are printing. So, for example, how much resin have you used? How long has certain prints have been printing? Also, the materials that you have in stock, how much of the materials you have left. And it also what I like, what's my favorite part about the dashboard, that you can, that if you give it your contact information, you will receive you will receive SMS notifications on your phone when a print has finished, when a print has started, and anything in between. And as you can see on the screen, Jakob is showing the dashboard. And basically, this is one of my favorite parts. Also, that the timeline where you can see when the print has started, when has stopped. This is especially useful when you have many printers. And also, I like the fact that it can label your library of materials that you have in stock. So basically, each time you use a new material, the dashboard will label that as the new material, and and it would also record over time how many prints with that cartridge, with that tank have been made, and so on. So it's a great base of information. Really, really handy, useful.
Yeah, so the dashboard is pretty cool, and you basically have shown most of the things pretty nicely. And just to show you as well, a cool thing that I find about, especially about the materials page, if you're in here, you can actually see tracked live which materials are inserted in which printer. So yeah, I can see right now that this is the very cartridge that I have just inserted into Gullible Spider. So I can see that it has 600 milliliters are gone. So I know that this has approximately 400 milliliters left. And you can also, in the prints, you can export everything as a nice Excel file so that you can basically do a little bit of a calculation how much resin you're taking for like a given month or over a longer period. There's also a very nice question again. So can you use these printers remotely? Yes, you can. So let me very quickly just go over to the printer to show you this.
I just switched microphones again. I hope you can hear me well. So on the printer itself, there's basically a little click that you can do. I'm going to zoom in again, so I hope you can see this a little bit. I think it's hard to see, but let's see if I can get this here. Sorry for this. So if I'm on the home screen, so I have two options right now. This was the last print that I just uploaded, so I can just start to print this. But if let's say this was done and I'm just taking everything out, what I can do is I have this little prime button right here, and the printer will basically guide me through the setup process. So inserting a tank, a build platform, and making sure everything is there. And then the printer will basically prime itself. That means it initializes everything. In this case, for example, it shows me, because I have been pushing this printer around quite a bit in the last couple of minutes just to make it fit into the frame very nicely. So it just showed me that the printer is tilted a little bit. So I should actually untilt it. And there's an option in here how to do that. But basically, after I have completely prepared the printer, now you can see that the button is red because I can also unprime it. Now I have the option through the dashboard to just upload a print from wherever I am. And as long as the printer has either internet access or you have access to the network that you want to print this in, you can just from home, for example, just start a print. And then let's say this is in the office and I'm at home, I can start the sprint, and then when it's done, I can just go there, take all of the models, and then prime the printer again, go home, and a couple of days later, I can prepare a file, upload it, and then I don't have to go into the office twice to start the print again. So this is a very nice option. Or if you maybe have somebody on site, so let's say you're working from home right now, or you have a colleague who's, let's say, in the logistics department, you tell them like, hey, everything is already in the printer. Can you just press prime and hit next a couple times? They'll be, yeah, sure, no problem. Then they can print the printer for you, even if they don't have any knowledge about the machine at all. And then you can just upload and start printing.
Okay, I think that's all for the questions. So if you have any additional questions, of course, you can contact us or Formlabs, so we will try to answer them. So thank you for joining us. Thank you for your attention, and we'll see you next time. Okay, bye.
Thank you.
Thank
Bye.
you. Bye-bye.
Goodbye.
Bye, everyone.